Hi students, all of you welcome. Welcome to Sunil Engineering Academy. I am Sunil Kumar Bandar. Students, in this chemistry series, we have already completed two sessions. It is the third one. In the previous sessions, we have completed acids and bases, salts. In this session, we are going to discuss pH scale, another very important topic. Okay, and students, I have already told that if you just open and skipping this video means you may not get anything, so don't do like that. Just to follow 2 to 3 sessions, then you surely will get idea. Still you may not get, you can skip. Okay, pH scale. What is this pH scale, guys? Is nothing but a scale. Okay, so for example, we are going to measure any object by using a scale that is having 1 centimeter, 2 centimeter, 10 centimeter, 100 centimeter, or meter, kilometer, like that. Okay, in the same way, if you have any one chemical, any one solution, any one chemical or any one solution, how we can say that solution is belongs to strong acid, strong base, weak acid or weak base, or it is a salt. How we can say? By using the pH scale. Okay, so it will give the idea the solution is belongs to acid or belongs to base or belongs to salt. Okay, so pH scale is nothing but it is a scale used for the measurement of acidity or basicity. Okay, don't worry, I will give the words. So it is one of the scale. Okay, not it is actually it is in the bend manner. Trying is difficult by using the pen tab. Okay, so pH scale generally starts from 0 and ends at 14. Okay, so pH scale 0 to 14. In the middle we have 7 na 7. Okay, so 0 to 7, if the pH scale belongs to 0 to 7, we can say those are acids. That means the pH scale is less than 7. pH is less than 7. We can say those are acids. If the pH is between 7 to 14 or more than 7, we can say those are bases. Okay, those are bases. That means more than 7. Let us take more than 7. Like here, the pH is more than 7. If it is exactly 7, the pH is exactly 7. We can say those are neutrals. Okay, those are neutrals. So once again, pH scale starts from 0 and ends at 14. Okay, so 0 to 7 are acids. Whenever the pH is less than 7, those are acids. pH is greater than 7, those are bases. Okay, and whenever pH is very near to 0, those are strong acids. Those are strong acids. In the same way, pH is near to 14, those are strong bases. Those are strong bases. Okay. So whenever the pH is less than 7, those are acids. Greater than 7, bases. Exactly 7, neutrals. If the pH is very near to less value, that is 0, very near to 0, those are strong acids. Very near to 14, those are strong bases. So note down the important points here. pH value or pH scale. pH value is the measure of acidity, or basicity or basicity. Okay, basicity. Here, if the pH is less than 7, those are acids. The pH is greater than 7, those are bases. The pH is exactly 7, those are neutrals. Those are neutrals. Okay, all of you getting up to this? Those are neutrals. Here, let us take a very important point belongs to acids. So, in the acids, what is the common element we have? Let us take any acids: HCl, H2SO4, HNO3, CH3COOH. Let me know any one common element. So generally all are non-metals. In that common element is here hydrogen, here hydrogen, here hydrogen, here hydrogen. So hydrogen is the most common element, correct? So that means acids generally we can say those have hydrogen ion concentration, H plus ion concentration. Okay, so those having H plus ion concentration. Whenever this H plus ion concentration is high, if the H plus ion concentration is high, then we can say that is the strong acid. Okay, whenever it has more H plus ion concentration, we can say that is the strong acid. If the H plus ion concentration is low, we can say that is the weak acid. That is the weak acid. In the same way, let us take the bases. Some examples. The bases NaOH, okay, KOH, calcium hydroxide, calcium hydroxide. Let us take all these. What is the common element? OH, OH, OH. Okay, that means if you take the solution Na plus OH minus K plus OH minus Ca plus 2 OH minus 2. So that means here OH minus ion concentration is common in the bases. Okay, here H plus ion concentration in the acids. The same way OH minus ion concentration is in the bases. Whenever this OH minus ion concentration is more, we can say that is the strong base. Strong base. Whenever the OH minus ion concentration is less, we can say that is the weak base. This is a simple idea. Okay. So if any solution is belongs to a strong acid, then we can say that having high hydrogen ion concentration. If any solution is belongs to strong base, you can simply say that OH minus ion concentration is more. Okay. So this is the basic thing. Okay. So that means from this, what we can say, strong acid means more hydrogen ion concentration. H plus ion concentration is more here. Here strong base means OH minus ion concentration is more. So 0 at 0 H plus ion concentration is more. At 14 OH minus ion concentration is more. That means from neutral to 0, what is happening, guys? Whenever you are going from 7 to 0, what is happening? H plus ion concentration is increasing now. H plus ion concentration is more at 0 means from 7 to 0, what is happening? H plus ion concentration is increasing. Okay, so you can note down one important point here. From 7 to 0, H plus ion concentration is increasing. H plus ion concentration is increasing and becomes more acidic. More acidic. Okay, that means finally what we can say, as H plus ion concentration is increasing, acidity is increasing. Acidic nature is increasing. Okay, so we can give this one in a formulatic manner. pH is equal to minus log H plus ion concentration. That means if minus comes here, log 1 by H plus ion concentration. That means as H plus ion concentration is increasing, pH is decreasing. Okay, so we can make this one here as H plus ion concentration increases, pH is decreasing. That means coming near to 0. Or pH is decreasing. That means acidic nature increases. Okay, pH near to 0. All of you getting this point? Very, very, very important. Very, very important. What I am saying, from 7 to 0 means H plus ion concentration increases. So H plus ion concentration increases means acidic nature increases. Okay, so we can take here as H plus ion concentration increasing. What will happen? pH is decreasing. pH is decreasing 7 to 0. Here, what about this OH minus ion concentration? As OH minus ion concentration increases from 7 to 14, what will happen? 7 to 14. 14 means strong base. That is, basicity increases. So you can note important point here. As OH minus ion concentration increases, basicity increases. And what happened to the pH? pH is increases from 7 to 14. That means as OH minus ion concentration increases, pH value increases. pH value increases. Okay. So here in the acid, what will happen? Inversely proportional. As H plus ion concentration increases, pH is decreases. Decreases means it will become strong acid. Acidic nature increases means near to 0 means strong acid now. So but here as OH minus ion concentration increases, pH is increases, so it will become strong base. Becomes strong. Okay. So once again, guys, less than 0 means acidic. Less than 7 means acidic. Greater than 7 means basic. Exactly 7 means neutrals. So 0 means strong acids. 14 means strong bases. Strong bases. Okay. So from 7 to 0, H plus ion concentration increases. From 7 to 14, OH minus ion concentration increases. Okay. So here, as H plus ion concentration increases, what will happen? pH is decreases from 7 to 0. So becomes more acidic. As OH minus ion concentration increases means pH increases from 7 to 14, that is basicity increases. So I have given the same points here. As H plus ion concentration increases, pH is decreases. Acidic nature increases, that means becomes more acidic. As OH minus ion concentration increases, pH is decreases from 7 to 14, that is 14 becomes a strong base now, so it will become strong base. pH is decreases means 7 to. Okay, so this is the pH scale. So how we can say any solution is strong acid or strong base or weak acid or weak base? If any solution pH is near to 0, that is 1, 2, 3, up to 3 we can say that is a strong acid. Okay, greater than 3, that is like a 4, 5, 6, that is you can say weak acid. Weak acid. So you can say if it is 3, up to 3, strong acid. Strong acid. Here also up to 10 is a weak base, more than 10 strong base. pH is more than 10 to 11. Okay, you can say strong. So like that you can get the idea. Like that you can get the idea. Okay. So pH scale is also one of the indicator. Solution is acidic or basic in nature. Okay. So noted all these points. Noted all these points. Now let us take some important solutions and those pH values. Very important for exams, guys. Okay. Very important for exams. Let us take pH value. It is in the order of 0 to 1. If it is in the order of 0 to 1, that is nothing but H2SO4 is the example. Sulfuric acid. It is also called as battery acid. Na? Sulfuric acid is also called as battery acid. Okay. If the pH is nearly 1.2 to 2, that is HCl, hydrochloric acid. Hydrochloric acid. What is the another name? That is stomach acid. The acid present in our stomach, that is nothing but acetic acid. Okay, that pH value is 1.2 to 2. So are also called, we can say, gastric acid. Gastric acid. If they are asking exactly, you can give 1.2. Okay, so that means these are very, very strong acids. Very, very strong acids. And HNO3 also. HNO3, nitric acid, that is also belongs to 1.2 to 2 only. Okay, let us take some lemon acid, 2.2 to 3.4. That is lemon juice. It is also very important question. The lemon juice. What is the acid present in lemon juice? Citric acid. Okay, citric acid. So in case of lemon juice, the pH is nearly 2.2 to 3.4. It may be very based upon different types of fruits in this lemon. Okay, lemon types. Now coming to orange juice. Orange juice, I'm having some more, 3.2 to 3.9. Orange. Okay, orange juice. Now coming to 4.1 or 4 to 4.4. Tomato juice. Tomato, we have oxalic acid. Tomato. Okay, let us take coffee. 4.5 to 5.5. Coffee. That means from this you can get the idea coffee is acidic in nature. So don't suggest the coffee to the persons who are having stomach problems, that is gastric problems or acidity problems. Okay. Now coming to milk, 6.4 to 6.6, cow's milk. So milk are also a little bit acidic in nature. Okay, coming to the 7, pure water. Pure water. Okay, now coming to after 7, 7.3 to 7.5. That is our human blood. Very, very important. Our human blood is slightly basic in nature. Correct? Slightly basic in nature. So more than 7 na? So slightly basic in nature. So exactly you can say 7.35 you can consider. And 8, very, very important. Seawater. Seawater is also a basic in nature, that is having 8. 9, baking soda. Baking soda. So baking soda is one of the weak base. Okay. Now coming to, let us take 10 to 11. These are antacids. Antacids. Very, very important question. So for antacids we are using milk of magnesia, that is a medium base. Medium base. I already don't know what is the milk of magnesia, magnesium hydroxide solution. Okay, so generally we are using the medium base. Why we are preferring the medium base in antacids? Why can't strong bases? Why? Because as same like strong acids are very harmful to our human body or our human skin. Correct? If any one drop will fall on our skin, that is one drop of strong acid fall on our skin, what will happen? It will burn. Okay, our skin is damaged. Correct? In the same way, strong bases are also very harmful. If you take some sodium hydroxide, NaOH, and that add into the water, and if you pour on your hand like that, then your skin may be damaged. Okay, so don't play with that bases also. Okay, bases are also strong bases. All strong are harmful only. Okay, so but some of the weak bases like tomato juice, coffee, cow's milk, orange juice, those are nothing but weak acids. So those are not at all harmful. That means natural occurring acids. Okay, so from this you can say natural acids. These are weak in nature. Correct? This is a simple idea. Whenever they have given any one acid and they are asking that, for example, they have given oxalic acid, that is a strong or weak. If anyone asking, you can simply say that oxalic acid is present in tomatoes. That is a natural occurring acid. That means you can say weak acid. If anyone asking about that is H2SO4 is a strong or weak acid, that is industrial acids. Industrial acids are strong in nature. Simple idea. Industrial acids, strong acids. Okay. So that is a simple idea. Correct or not? Actually, we are not working on these chemicals. Correct. We are not working in the chemical factory to know all the experiments and finding the pH values and all those. Correct or not? So how we can say? We can say simply like industrial acids are strong acids and some natural occurring acids are some weak acids. Okay. So like that we can simply get the idea. And here weak bases are nothing but seawater, baking soda. If you take some baking soda on our skin may not burn. So we can simply say that those are weak bases. Okay, but don't try every chemical and touching your skin and like that. Okay, don't do like that. Okay, guys. Uh, and acids. After that, let us take some strong bases like pH of nearly equal to 14, NaOH, NaOH having exactly 14. Some of that is between to 11 and 14. We have some strong metals, strong metals like sodium, potassium hydroxide, calcium hydroxide. All these belongs to very, very strong bases. Okay, strong bases. So in this very important for exams, this is the very important. After that, lemon juice also sometime asking, pure water also asking, okay, and baking soda, antacids, blood. Okay, so these are the very important for exams. Note down all this. Okay, and also apart from this, you can also say that if any solution is the acid or base by using litmus paper, by using turmeric, okay, or by using methyl orange, methyl red, uh, and also universal indicators are also olfactory indicators. So some of more there is so many indicators are there to find out the solution is acidic or basic. We will discuss all those in this session only. Okay, so let us take some indicators. Okay, used to identify the solution is acidic or used to identify The solution is acidic or basic. Okay, what are the example? Litmus paper, turmeric, phenolphthalein. Phenolphthalein is a synthetic type. Important. Phenolphthalein and some olfactory indicators. Universal indicator and methyl orange, methyl red, methyl red, and all those. Okay, so let us take some some in detail about this. First of all, litmus paper. If you can consider a litmus paper, how it will behaves case of acid, in case of base. Okay, we know very well litmus. Acid converts blue litmus to red litmus. So finally, in case of acidic, it will use which color? Red color. Correct? It will use the red color. If you take blue litmus, it will use the red color. And in case of base, we have to take red color, and it will use the blue. So it will use blue color. Now coming to methyl orange and methyl red. Methyl orange and methyl red, and also turmeric and phenolphthalein. Okay, so phenolphthalein. Let us take methyl orange in case of base, and in case of acidic, how they will be behaves. Okay, so this litmus paper and this turmeric are nothing but, can say, natural indicators. These are nothing but natural indicators. And methyl orange, methyl red, phenolphthalein, those are synthetic type, that is chemical type of the indicators. Okay. So in case of methyl orange and methyl red, in case of acidic, they will give, in case of acidic, they will becomes red color. In case of base, they will becomes yellow color. Becomes yellow color. And acidic, the turmeric, no change. No change means yellow color only. Turmeric is yellow color na, so it is yellow color only. Example, lemon rice. Okay, in the lemon rice, lemon is the acidic in nature na, so we are adding some turmeric. Whenever we mix it together, also turmeric having is in having yellow color only, no change. But in case of base, if you add some tuna powder to the turmeric, it will becomes red color. Will becomes red color. Okay, and phenolphthalein, how the phenolphthalein behaves? Come on, anyone? Phenolphthalein is the uh, synthetic type of the indicator. Okay, so in case of base, it is pink color. In case of base, it is in the pink color. In case of acidic, it will becomes colorless. Colorless. Okay. So in acidic, litmus, red color, methyl orange red, methyl red also red. Okay, turmeric, no change, phenolphthalein, colorless. But in case of base, they will behave like blue, yellow, red, pink. Okay. Completed. Very important. And what about the olfactory indicators? Olfactory indicators. These olfactory indicators are nothing but they have distinct smell. Okay, so substance whose smell changes in the solution, that is solution may be acidic or base. We can get the idea by using these indicators. Okay, that means the smell, if the smell changes, that belongs to acid or that belongs to base, like that we can get the idea. Okay, so note down those indicators whose smell changes in acidic or basic. Those are nothing but olfactory indicators. Examples: onion, vanilla, clove. Okay, so these indicators are generally, you can say, olfactory indicators. In case of acid, may not loses the smell. These are may not loses smell. Okay, but in case of base, those will be losses. So based upon that, we can get the idea the solution is acidic or basic. But we may not get exact pH value or exactly that is strong or weak. Just if it loses the smell, we can say that is the base. If it is not losses, we can say that is the acidic. Okay. But by using the universal indicator only, we can get the exact pH. That is, the solution is strong or weak. Okay. So universal indicator. By using this, we can say solution is strong acid or weak acid, comma, strong base or weak base. Weak. Okay, how we can get idea? Here, by using the table, we can get the idea if it is a pH range and description and color. Okay, if you have given any solution having pH is less than 3, you can say that is a strong acid. Now, that strong acid, if you add some universal indicator to that strong acid, it will becomes red color. It will becomes red color. So if you add some universal indicator drops to the strong acid, that will gives red color. Okay, if it is belongs to more than 3 and less than 6, okay, that is, you can say 3 to 6, then you can say somewhat of weak acid. In this case, it will becomes as some orange or yellow color. Orange or yellow color, or mixture of orange and yellow. Whenever it is 7, that is, you can say description means 7 means neutral. So in this case, it will gives green color. Okay, if it is green signal, you can say that is it is neutral. That is not harmful to us. Okay, we can feel like that. Now coming to more than 7, 8 to 11, up to that one, it is a weak base. If it is a weak base, it will give a blue color. Okay, that means it is like a alkaline water. Alkaline water means some basic water. Okay, basic in nature. So basic in nature means that a weak base so can get blue color. So more than 11, very strong base. Very strong base. Strong base means it will be it gives violet or indigo, very dark blue or violet color. Okay, so by using that, that means your universal indicator, we can get the idea that is some exact pH value, that is some exact pH. So we will get the question like that in the following: which of the indicator you use to find out the exact pH? That is universal indicator. Okay, universal indicator. And one more question on this phenolphthalein, it is a synthetic type. This was also synthetic type of the indicator. Litmus turmeric natural type of the indicator. Okay. Sometimes they will give the question in the which of the following indicators converts the solution into red color in acidic. So which are converts red color in acidic? Litmus, methyl orange and methyl red. Okay, so like that we may get the question. Don't worry, we will discuss uh, new, that is multiple choice MCQs. Okay, topic wise MCQ. After completion of this theory, we will take MCQs. If any point is not covered in the theory, that will covered in the MCQs. That's why follow each and every session. Okay, follow each and every session. So once again, guys, so in this session we are discussing about the pH scale. So less than 7 acid, more than 7 bases, exactly 7 neutrals. Okay, as H plus ion concentration increases, pH is decreasing, that becomes more acidic in nature. As OH minus ion concentration increases means pH also increases, so becomes more basic. Some of the important points here. Okay, so if any point is not covered here, that will covered in the MCQs. Don't need to worry about that. And some indicators and how they will be convert the solution in acidic and in basic. Olfactory indicators, that is by using the smell we can get the idea. So in acidic, it may not lose smell. In case of basic, loses the smell. Okay, and universal indicator and those colors. Okay. The next session we will discuss the MCQ. Okay, that it will be very interesting session. Okay, so up to this you have to prepare all this theory and attend for the next MCQ session. Okay. Okay, students, and I need your comments and suggestions also. So you can give your suggestions by typing in the comment section. Okay, thank you so much, guys.